Hello, everyone. The purpose of my research is to design, synthesize, and characterize a thermoplastic lignin-based polymer to replace an equivalent for a petroleum-based polymer. Through this research, we will be able to reduce the waste created by the pulp and paper industry, lower our petrochemical consumption, as well as produce high-performing materials. Currently, I have completed the first stage of my research, which is microwave pyrolysis of craft lignin to produce bio-based monomers in the form of bio-oil. Due to the heterogeneous nature of craft lignin, we carried out approximately 50 trials in this stage. The research objectives for this stage was to optimize the yield of the bio-oil as well as the phenolic content in the bio-oil by varying the type of microwave receptor, that is the biochar type, as well as the microwave pyrolysis power level applied. The bio-oil obtained in this stage consisted of two phases, the light phase and the heavy phase, and they have been denoted by BOL and BOH. The varying factors affected our bio-oil yield such that with increasing power level, the bio-oil yield also increased. Additionally, it can be seen that in the presence of spruce biochar, the bio-oil yield was larger as compared to when hemp biochar was used. With the gas chromatography and mass spectrometry analysis, it was observed that the phenolic content was over 90% for most of the heavy phase oil. At lower power levels, that is 300 to 450 watts, the phenolic content was larger in the heavy phase when spruce biochar was used, while the phenolic content in the light phase was larger when the hemp biochar was used. At 600 power level, it was observed that hemp was favorable for both phases in the bio oil. Based on our results, it was concluded that the spruce biochar was a favorable microwave receptor to be used as it can combine a good yield as well as good phenolic content in the bio oil. Additionally, with the GCMS testing, it was concluded that the high phenolic content in the craft lignin bio oil proves its eligibility to replace petroleum-based monomers. In the upcoming weeks, I will be polymerizing the bio-oil created into a thermoplastic polymer. The thermoplastic polymer will then be characterized to investigate properties such as viscosity, glass transition temperature, and thermal stability, and then compared to current standard petroleum thermoplastics available. Working with industrial partners, the novelty of this research in terms of the low viscosity bio-based thermoplastic resin sets the stage for a new standard development for its application in several industries, especially for pultrusion composite manufacturing as a polymer matrix. Hence, this research has the merit for securing an intellectual property creation. Additionally, the research is also supporting knowledge dissemination by publication of peer-reviewed articles on application of bio-based monomers to produce thermoplastics. Thank you for your attention, and please feel free to reach out to me with any questions.